Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. There's now well over 1,000 practice problem solutions, so please check out the whole channel, subscribe, and you'll get a new exercise every day. Here is information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam P. X is a random variable with a gamma distribution. The gamma distribution has parameters alpha equal to 3 and beta equal to 2. If a gamma distribution is represented as a sum of independent, identically distributed exponential distributions, then alpha is the number of exponential distributions added, and beta is the hazard rate of those exponential distributions. To find the new random variable y equals 30x plus 2x squared, find the coefficient of variation of y. And here's a solution. We can actually write x as t1 plus t2 plus t3, where each ti is exponential with hazard rate of 2. Therefore, e of x is 1/2 plus 1/2 plus 1/2, so it's 3/2. And the variance of x, because we assume these t1 and t2 and t3 are independent, is the sum of variances. And the variance of each one of them is the square of the mean, so it's 1/2 squared. So 3 times 1/2 squared is 3/4. And the second moment of x, therefore, is the variance of x plus the square of the first moment, which is 3/4 plus 3/2 squared. So 3/4 plus 9/4, that's 12/4 of 3. This gives e of y, the expected value of 30x plus 2x squared, as 30 of x plus 2e of x squared, so 30 times 3 over 2, plus 2 times 3, that's 15 times 3 is 45, plus 6, and it's 51. And furthermore, e of y squared is the expected value of square of 30x plus 2x squared. So it's the expected value of 900x squared plus 120x cubed plus 4x to the fourth. Okay. Well, we know e of x squared. We calculated it as 3. So 900 times 3 is 2700, and then we left with 120 e of x cubed plus 4 e of x to the fourth. In order to find e of x cubed and e of x to the fourth, we recall that the moment-generating function of x is m sub x of t equal to beta over beta minus t to the power alpha, which is just the power alpha of the MGF of exponential distribution with hazard rate beta. So this is 2 over 2 minus t cubed. Therefore, the first derivative of the MGF is the derivative of 2 over 2 minus t, and we calculate that to be 24 times 2 minus t to the negative fourth. So we take this 2 over 2 minus t cubed and make it into 8 times 2 minus t to the negative 3, and then we get this answer. The second derivative is the derivative what you see here, and that's going to be 96 times 2 minus t to the negative fifth. And the third derivative will be the derivative of what you see here, which will be 480 times 2 minus t to the negative sixth. And then the fourth derivative, finally, the one that we need for the fourth moment, will be a derivative of what we see here, and that's 2800 times 2 minus t to the negative seventh. Well, okay, then e of x cubed is the third derivative evaluated at 0, so it's 480 times 2 minus 0 to the negative 6, which is 15 over 2, and the fourth moment is the fourth derivative evaluated at 0. That's 2880 times 2 minus 0 to the negative 7th, and that's 45 over 2. Oh, then therefore, E of y squared is 2700 plus 120 times 15 over 2 plus 4 times 45 over 2, and that's 3690. And therefore the variance of y is E of y squared minus the mean of y squared. That's 3690 minus 51 squared, and that's equal to 1089. And the coefficient of variation is the standard deviation divided by the mean. So it's the square root of 1089 divided by 51. It's 33 over 51, or 11 over 17, and that's approximately 0.647058882, and that's answer A. Please remember, this is copyrighted material. The problem was created by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.